we also need to think about how we look at definite integrals in different ways. So we had our classic way of just anti-deriving, plugging stuff in, and then getting a value. But this one, we have let f be a continuous function that such that the integral from negative 2 to 9 of f of x is negative 7. The integral from 9 to 10 of f of x is equal to negative 3. What is the value of the integral from negative 2 to 10 of f of x plus 2? So first thing that we can do is this integral that we're dealing with, the integral from negative 2 to 10 of f of x plus 2 dx, we can split this up into two different integrals. So we have the integral from negative 2 to 10 of f of x dx plus the integral from negative 2 to 10 of 2 dx. From here, I have two separate integrals that we're going to look at. So we're going to focus on this first one. So the integral from negative 2 to 10. So we have the integral from negative 2 to 9 and the integral from 9 to 10. So we're going to combine those two. So we have the integral from negative 2 to 9 of f of x dx plus the integral from 9 to 10. And this is going to be what makes up the integral from negative 2 to 10. I'm going to go ahead and integrate 2 in a second. So we're going to focus on this first piece. So I have the integral from negative 2 to 9. Well, that equals negative 7 because that's what the problem told us. Plus the integral from 9 to 10, which happens to be negative 3. And then whatever we get over here. So now what I'm going to do is we're going to anti-derive this value over here. So we have the integral of 2 on the interval of negative 2 to 10. So the antiderivative of 2 is 2x, and we're going to evaluate for that from negative 2 to 10. And then I'm going to go ahead and plug in my values. So I have 2 times 10, and I'm subtracting 2 times negative 2. So if I combine these, we get negative 10 plus 20 minus, and then 2 times negative 2 is a negative, so we have plus 4. So we have minus 10, or negative 10 plus 20 plus 4. Negative 10 plus 20 is going to be a positive 10, so our final answer is going to be 14. So this is a couple different things together. Sometimes they will give you problems where they give you information like this, and they may want you to find just this part. And they also could add more stuff like they did here. And then our last one here, write an integral that is equivalent to the integral from 0 to 1, x times f of x times, oh my gosh, x times f of 4x squared minus 2 dx. So one of the things that you're going to know is that this is actually a U substitution problem. And we don't actually have to find the actual answer to the definite integral. We can if we want to, but we don't have to, because it just says write the integral that is equivalent. So the first thing I'm going to do is I'm going to use U substitution. So I have U, and I'm going to make it equal to our inside function, the stuff inside of f of x. So we have U is equal to 4x squared minus 2. The derivative of this, 8x dx. So if I look at what I have, that x is the x is there, the x is there, but the 8 is not. So I'm going to move the 8 over and have 1/8 du equals x dx. So we're going to go ahead and plug what we know in. So I have the integral, and I'm going to leave the bounds for a second. We have f of u. I need a 1/8 in here. du. So before I get too far, I need to do my intervals. So I have our intervals in terms of x, and I need to plug them in to our u equation to figure out what they would be in terms of u. So our upper bound, we're going to do b upper, is equal to 4 times 1 squared minus 2. 1 squared is 1, times 4 is 4, minus 2. So we have 4 minus 2, which is 2. So this right here is our upper bound. Our lower bound, we have 4 times 0, minus 2, so negative 2. So I'm going to bring the 1/8 out front. The integral of negative 2 to 2, f of u du. And we don't know what f of x is or f of u is, so we have to kind of just leave it. And this could be our answer because this is an equivalent form. A lot of times what they're looking for, especially in a question like this, it might be a multiple choice question. They're looking for, did you get the bounds correctly? Did you get the coefficient right? Things like that.